Hello and welcome to the wonderful world of oxy-acetylene welding, Chapter 4. Alright guys, we're going to talk about oxy-welding, we're going to talk about some oxygen, some acetylene, and how to blow ourselves up. Alright, here we go. Alright, so let's start with the beginning. We need a protector cap. What does the protector cap protect? Well, protector cap protects the cylinder valve. This is the weakest part of our cylinder, so we want to put a cap on it. Should it fall, it can explode. Okay, so we want to make sure that we always protect it. We don't ever want to move it without protecting the cylinder cap. We don't want to grab it from there or anything like that because we can cause some problems. Okay, an acetylene cylinder. Okay, what happens is that they put, it used to be kind of like this balsa wood that they would put in it. It's kind of like this funky, porous, kind of foamy stuff that they put in there. And they fill it with acetone. And then they're able to put in the acetylene, and it keeps it stable. Okay. And what we have are gas relief openings here and fusible plugs. So if the pressure gets too high or too hot, these release the gas, okay? Now, there's another safety right here. This is our cylinder valve, okay? There's a safety right here on the other side of the valve. If the pressure becomes too high, the valve will start to pop off. Okay, now, acetylene, it can become unstable, okay? And this is the only time I'm going to get a little crazy with you guys, is the safety of acetylene, okay? Acetylene cannot be run over 15 PSI, period, okay? It becomes unstable, and you can blow up everybody, okay? So this is, I might get a little, bananas on you saying, hey, what are you doing? That's because of this, okay? This endangers everybody if you do not know what you're doing. So if you have questions, you're uncertain about something, you say, hey, what do you think about this? I want to be safe, okay? 15 PSI is the maximum working pressure of acetylene. Okay, now, cylinder valve, okay? Cylinder valve is right here, okay? And we're going to attach our regulator. This regulator is a two-stage regulator, which tells us the pressure that's inside of our tank and what is our working pressure, or how much pressure is going out, okay? Whenever we open an acetylene, okay, a tank for acetylene, we want to open it slowly, and we do not need to open it all the way. It has a special type of valve that allows us only to open as much as we need. I believe the book says 1/2 to 3/4 turns. Now, why would I think about using 1/2 to 3/4 turns? Well, the thing is that if I have to turn it off in an emergency, I want to be able to turn it off as quickly as possible. Think about it. If it's open a whole bunch, how long is it going to take me to screw it back in? Meanwhile, it's, fires going everywhere and things like that. So we want to make sure that it's closed. We are able to close it very quickly. All right, now at school, this is what we have. It's called a manifold system. This means I'm able to put acetylene on one side, and I'm able to put oxygen on the other. And what I have in the center is called a flash arrestor. The flash arrestor actually has a fluid inside and a pressure, okay? And I'm able to set the pressure for each one of these. And what happens is that it allows us to deliver gases, whether they're oxygen, acetylene. I can do any type of gases to different welding stations, okay? This flash arrestor makes sure that if there's any type of spark or flash that comes back, it comes back into that and it stubs it out, okay? Cylinders. We want to be careful with cylinders. Cylinders can explode. So maybe I'll find the video for you guys, but they talk about what happens when a cylinder comes apart. We don't want to be around any type of big magnets. It can come apart. They can explode. if the cylinder valve comes off. We can make it go through brick walls. Okay, so we want to make sure that we're always keeping it upright. Also, because of the way different types of cylinders are packed for the different gases, they need to stand up. Okay, kind of like your refrigerator, we want to make sure it's up. Okay, so maybe I have to transport them in my truck, which means I'm probably going to lay them down so they don't go bouncing hit a pothole. Here goes the acetylene flying out of my truck. So what we do is we'll lay them down, and then once we get them to where we need to go, they need to stand for at least 2 hours. Okay, even before we can use them, and that way we can make sure that everything resettles and it's appropriate and it doesn't cause any issues. Okay, of course we want to make sure that we chain them. Here's the thing. We do not want to store oxygen and acetylene together. In a manifold system, we want to actually have a 5-foot wall in between them to make sure that they don't intermix should anything happen. Oxygen and acetylene means boom. All right. Now, we're going to talk about some equipment. Okay, so this is a little bit of little small picture, but let's talk about this. Okay, so we're going to need acetylene. We're going to need oxygen. We're going to need a particular regulator for acetylene and a regulator for oxygen. We're also going to need the appropriate hoses. And some people have a little truck for it. Other people, like us, we have a manifold for it. We're also going to want to use a sparklighter, and we're going to want to, use a dark pair of goggles. Okay, so here, this is a welding torch. They call it a blowpipe, and it actually mixes the oxygen and acetylene inside, and it comes to the tip where it is burnt. Okay, right here, these are called packing nuts. In here is a needle valve. So what it is that the needle valve allows the flow of gas. So the more we open it, the more the needle is removed from that little area. The tighter it gets, the tighter, more the needle gets pushed into the area so that the gas doesn't come out as much. A tip cleaner. When we use a torch, torches tend to get soot. And sometimes we get little spatters and such. Okay, so we need to make sure that we clean it. In order for us to clean it, we actually turn off the acetylene and we leave the oxygen on. Okay, this allows any type of foreign material or any soot to get blown out. Rather, it gets stuck. We don't want it to get stuck in this area because it'd be really hard to get out. Okay, so we want to leave the oxygen on. So the first thing is that we get our tip cleaner, and there's this little, and ultimately a tip cleaner is like a little teeny tiny file. Okay, so this one right here is a flat one, and the flat one is for the front of the tip. Okay, and then once we've kind of cleaned up the front, we're going to do the interior. So we're going to find a tip that is the same size as the hole, and then you can get it in and out. And we're filing around the little orifice to make sure that there's nothing in there. Okay, it'll help make a better flame, and it'll be more consistent. When we have a dirty tip, what'll happen is the flame will split or the flame will spit, and it won't give you the desired results that you're looking for. Oxygen and acetylene regulators. Okay, let me show you here. Okay, so this is an oxygen regulator. Notice that it is green, okay? And if you see here, it says use no oil, and some of them say oxygen only, okay? This one is this is a 2-stage regulator. This one says our cylinder pressure. This is how much is in my tank. This is my working pressure. This is how much I'm letting out, okay? And this is my adjusting screw, okay? This adjusts my working pressure, okay? This is right-hand threaded, okay? Now let's look at the difference between acetylene, okay? Same thing, this is a 2-stage pressure regulator. Here's my cylinder pressure. Here's my working pressure. Notice it says use no oil, but also says acetylene only. And if we notice, let's see if I can get really, really close. Maybe not. It says 15 psi, okay? Anything over 15 psi is in the red, which means bad idea, guys. Okay, same thing. Here is my adjusting screw, but notice this is called an angular notch. An angular notch tells me it is reverse threaded or left hand threaded. And notice the nipple here. Okay, it's a different adapter. It's a different fitting so that we can't put it on the wrong type of tank. Okay. All right, onwards. Here is our torch. Okay. Come back. See if I can make this bigger for you. All right, here we go. So what happens is, here's our oxygen, and here's our acetylene. And what these are called are check valves. Check valves only allow the flow of gas or a fluid in one way. Okay, that means it can't come back. If we have a spark or a flashback or a backfire, it doesn't allow it to go down into the hoses and into the tank and cause a fire or explosion. In the back in the day, that's what would happen. Okay, so it only allows it to go in one direction. Okay, but so here's my oxygen, it's coming through here, and my acetylene. And depending on the type of torch it is, whether it mixes up in this area or in the body area, but it mixes, okay? And it mixes together and it comes out, okay? And this is where it's lit, okay? So we're lighting it here. What happens with a backfire is that it comes back and we're actually having a little fire in here, okay? And it'll sound like, okay? We have a little fire, or if it's overheated, if there's an obstruction, we can cause issues in here and cause a backfire, okay? Now, what's the difference between a backfire and a flashback? Well, a flashback means that it is flashing back. A backfire means that I have changed either my fuel, my air, or my spark, okay? So if I get too close to my workpiece, I can smother it from any of those and it will go out, or to go pop, 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 being a flashback, kind of like a backfire in a car. All right, now we also need to understand that hoses are non-permeable. What does non-permeable mean? Well, non, we say no. Permeable. Permeable means that it can go in and out through something, okay? So the type of hoses that are used allow it not to go through the hose. If we use a different type of hose, let's say like a hose for water, it could go through and it could leak and we can cause an explosion, okay? We don't want that. So there's special types of gas hoses specifically made for this. We also need to make sure that we do not repair them with tape. Anything like that, it still makes it permeable, which means it can go through and cause issues. There's actually special repair kits that are used if you have a cut or a burn in your hose. Okay, notice the angular notch. Okay, this is left-handed thread. This is right-handed thread. All right, a sparklighter or a striker. Personally, I call them sparklers because that's what they do. Why would we use this over something else? Why would we not use a match or a lighter? Well, we need to remember, if I'm holding that match and that torch catches, what's going to happen? I'm probably going to burn my hand, right? Now, okay, let me use a lighter. Well, think about it. We can have a flashback into our lighter, which means all of that fluid catches on fire. Now my hand's going to explode, okay? So we want to make sure that we're using a striker or a spark lighter, and we want to make sure that we're aiming it down and away from somebody so we don't catch them on fire. All right, of course, there's always a recommendation for how not to burn your eyes out, okay? Now, when we're doing gas welding, we're probably going to want to use a shade 4 or 5. Normally, if we use 5 or 6 or 6 or 8, it's for a lot darker. When we get into plasma cutting, guys, it's recommended that you guys use your hood. The plasma is coming out at 14,000 degrees, and there's a lot more UV light than we expect, and we don't understand how much damage it can damage our eyes. So I asked you guys, please wear your hood when we're plasma cutting. All right, we're going to do the points to remember on another video. Be safe, guys.